simple projectile motion problem. We're going to start with Katniss Everdeen on top of a wall, and she's going to be shooting an arrow. Now, the initial velocity of this arrow is going to be parallel to the ground, down here, and let's say that it is going to go at a rate of 15 meters per second. Really fast arrow, okay? And let's say that she is shooting it from a height of 50 meters. Two questions we want to know. How long is the arrow in the air? And second question, how far does it go? All right. First step for those of you that have been having trouble with this is I want you to list everything you know for the x components and the y components. Okay. Now, we see the initial velocity is 15 meters per second. What's the x component for this and what's the y component? Well, because it's being shot parallel to the ground, all of the initial velocity is in the x direction. So we're going to list the initial velocity for x as 15 meters per second. And since it has no component in the y direction of velocity, I'm going to list 0 meters per second for my initial velocity on the y side. What else do we know? Well, I don't quite know how far out my arrow goes yet, but I do know how far it will fall. So I can list my delta y as 50 meters. And I'm also going to call the down direction negative. So my delta y will actually be a negative 50. Okay? My delta x, I don't know. But it is something that I'm eventually asked to calculate. All right? Acceleration is something else that I should take into consideration. Acceleration in the x direction is 0 because we are not taking into consideration air resistance. The acceleration in the y direction is negative 9.8 meters per second squared, okay, because it is gravity. So now that I've got my displacements, velocities, and accelerations listed, I can start to work through some possible calculations, okay? How long is the arrow in the air is typically dependent on our y-axis, okay, because it is the acceleration due to gravity that is causing the arrow to fall. So I want to use my y components to solve for this. And based on what I'm given, using this equation, delta y equals initial velocity times time plus 1/2 at squared, is a good place to start. I can get rid of this entire part because the initial velocity is 0. So then I'm just plugging in the numbers that I have and rearranging for time. So t equals the square root of 2 times delta y over a. And keep in mind that you're taking the square root of this whole thing, okay? So time is the square root of 2 times minus 50 meters over negative 9.8 meters per second squared. For brevity's sake, I'm not going to use a calculator, and I'm going to round this to 10 meters per second squared, which is legal on the AP exam. So I get 100 divided by 10 gives me 10. Then I take the square root of it. So my time is just going to be square root of 10 seconds. Okay? But I still need to know how far does it go. So I'm going to use my time now. T equals square root of 10 seconds to help me out with the rest of what I know about the x direction. So how far does it go means simply solving for delta x. I'm going to use the same equation now, only now I'm applying it to the x direction. And as we had already discussed, the acceleration in the x direction is 0, so that term goes away. And I get that the delta x equals the initial velocity times time. Initial velocity is 15 meters per second. Time is square root of 10 seconds. Put those together, 15 times the square root of 10 meters. Okay, and now we've solved both parts of the problem.